Good morning. I am Dr. A. Kalai Selvi. Today I present the topic case-based expert system and hybrid design. In a case-based uses an explicit database of problem solution to address new problem solving situations. These situations may be collected from human experts through the knowledge engineering process or may reflect the result of previous search based success or failures. For example, medical education does not rely solely on theoretical models of autonomy, physiology, and disease. It also depends heavily on case histories and interns' experience with their patients and their treatments. That is one of the example. Lawyers select past law cases that are similar to their clients and that suggest a favorable decision and try to convince the court that these similarities merit similar findings. Although general laws are made by democratic process, their interpretation is usually based on legal precedents. How a law was interpreted in some earlier situation is critical for its current interpretation. Thus, an important component of legal reasoning is identifying from case law precedents for decisions in a particular case. That is, computer programmers often reuse their code, adapting an old programs to fit a new situations with similar structure. Architects draw on their knowledge of pleasing and useful buildings of past to design new buildings that people find pleasing and comfortable. Historians use stories from the past to help statesmen, roots current and citations understand past events and plan for the future. The ability to reason from cases in fundamentals to human intelligence. That is, other obvious areas for reasoning from case include designs where aspects of a successful execution may be appropriate for a new situation, and diagnosis where the failures of the past option reoccur. Hardware diagnosis is a good example of this. Is an expert in this area, besides using extensive theoretical knowledge of electronic and mechanical systems, bring past successful and failed experience in diagnosis to bear on the current problem. CBR has been an important component of many hardware diagnosis systems. It includes works on the maintenance of signals resources and batteries in Earth orbiting satellites. CBR offers a number of advantages for the construction of expert system. Knowledge acquisition can be simplified if we record a human expert solution to a number of problems and let a case-based reasoner select and reason from the appropriate case. This would save the knowledge engineers the trouble of building general rules from the experts' examples. Instead, the reasoners would generalize the rules automatically through the process of applying them to the new situations. Case-based approaches can also enable an expert system to learn from its experience. That is, after reaching a search-based solution to the problem, a system can save that solution, and also that the next time a similar situation occurs, search would not be necessary. Okay, the next, it can also be important to retain in the case-based information about the success or failure of previous solution attempts. Thus, case-based reasoning offers a powerful model of learning. Then the case-based reasoners share a common structures. That is, first one is retrieve appropriate cases from memory. A case is appropriate if its solution may be successful applied to the new situation. Since reasoners cannot know this in advance, they typically use the heuristic of choosing cases that are similar to the problem instance. That is, both human and artificial reasoners determine similarity on the basis of common features. That is, for example, if two patients share a number of common features in their symptoms and medical histories, there is a good probability that they have the same disease and will respond to the same treatment. Okay, the next, retrieving cases efficiently also requires that the case memory be organized to aid such retrieval. Then the next one is modify a retrieval case so that it will apply to the current situation. That is, a case recommended a sequence of operations that transforms a starting state into a goal state. The reasoners must transform the stored solutions into operations that are suitable for the current problem. The next one is analytic model, that is such as curve fitting. The parameters common to stored cases and the new situation can be useful. For example, to determine appropriate temperature or material for welding. Applied the transformed case, it modifies a stored case, which, that is, when applied or may not guarantee a satisfactory problem solution. This may require modifications in the solution case, which further iteration of these first three steps. Next one is save the solution with record of success or failures for future use. Storage of the new case requires updating the index structure. That is, there are methods that can be used to maintain that includes clustering algorithms and other techniques from the machine learning. Okay, the next one is the hybrid design. An important area of research and application is the combination of different reasoning models. With a hybrid architecture, 2 or 3 methods are integrated to get a cooperative effect where the strength of one system can compensate for the weakness of another. That is, hybrid system is the combination of more than 2 models. That is, combination of rule-based and the case-based model. Offer a natural first check against known case before undertaking rule-based reasoning and the associated search cost. It provides a records of examples and exceptions to solutions through a retention in the case base. Then the next one is record search-based results as cases for future use. By saving appropriate cases, a reasoners can avoid duplicating costly search. Then the next one is combination of role-based and the model-based system. It enhances explanation with functional knowledge. This can be useful in tutorial applications. It improves robustness when rules fails. If there are no heuristic rules that apply to a given problem instance, the reasoner can resort to reasoning from the first principles. Then add heuristic search to model-based search. This can help to manage the complexity of model-based reasoning and allow the reasoners to, to choose intelligence between the possible alternatives. Then the next one is combination of model-based and the case-based system. In this, give more mature explanations to the situation recorded in cases. Offer a natural first check against stored cases before beginning the more extensive search required by the model-based reasoning. Then it provides a record of examples and exceptions in a case base that can be used to guide model-based inference. It records results of model-based inference for future use. Thank you.